Good morning to all. Today class we are going to discuss about wearable devices in healthcare. So wearable devices to monitor healthcare parameters, we can use so many devices day to life. So some of them are wearable fitness tracker, smart healthcare watches, wearable ECG monitors, wearable blood pressure monitors, biosensors. These are the some of the wearable devices available in the market. Still we have using so many devices day to life. Look at these examples for different wearable devices. So if you take in glass, we have the smart glasses. So it becomes an IoT based smart glasses. Look at this mouth guard. We have a smart mouth guards using this IoTs. Clothing, we have this smart clothing. It is also smart wearable devices. Strip, so that will be it's like a band. So that will be inserted in the hand to monitor the healthcare parameters. That is a strip. Belt, that is a smart belt. So that will be monitor the health parameters from human bodies. Headset, that is a smart headset to monitor the healthcare parameter also. Arm bands, so this also we have used this smart arm bands to measure the parameters. Watches, smart watches, that will be famous. Actually, smart watches not only meant for healthcare, but the actual smart watches, it has the inbuilt wearable content also. That is the inbuilt healthcare monitoring parameter also. So smart watches have some basic health parameters will be monitoring, like a temperature, and then fitness trackers, like how many steps we are moved, and then health parameters also. Look at this smart ring. So this is a famous one. So normally we use rings in a gold, but if you use this smart ring, it have the complete health parameter monitoring. Look at this smart shoes. So steps movement and other parameters, everything monitored with this smart shoes. If you see these, all the things that we need some microcontrollers and then some sensors to measure that parameters and then to control the devices. So that will be connected to the IoT cloud. So we need to use a Wi-Fi device or a GPRS devices. Look at this architecture, block diagram for a wearable devices. So here we use this controller. This is the microcontroller. So we use this. So for this we need to give some power supplies. So look at this power up button and then we have this voltage regulator. So normally we use batteries for this wearable devices because it is not possible to connect the power to directly to the controller or a wearable device. That's why we normally use this batteries. So here we have this push button. After that we have this voltage regulator. So voltage regulator is regulate the voltage and gives the constant voltage required for this controller. Look at this, we need this memory chip. So memory chip, it consists of both RAM and ROM. So without RAM and ROM, it is not possible to work the controllers. So the ROM is important to store the programs. Then only even if there is no power, the data will be retained. And then RAM is most important. Whenever we have the input data or whenever you are computing some data, that results cannot be stored in ROM, that will be stored only in RAM. So for that we need the RAM also. So memory chip, it consists of both RAM and ROM. And this LCD, it may be EBDD or TFT display, any one type of LCD display is important because then only we can track the results. So whatever we want to display, what the system condition, so these will be displayed in the LCD panel. Look at this, this is a Bluetooth. Whenever we need to connect our fitness tracker or our healthcare device to our mobile phone or other system, we need some communication technologies. So the basic communication technology here used is Bluetooth. So we can use a Bluetooth or a Wi-Fi or any other medium wireless technologies for the communicating from a microcontroller to our mobile phone or a system. Look at this. This is some of the sensors that will be used for healthcare parameter measurements. That is a tracking of health records. Look at this. Here we are using this heartbeat measurement sensor. It will measure this heartbeat of the human bodies. See, normally sensors can be interfaced both in analog form or digital form. If you interface in analog form, what happens? So exact value can be measured from the sensor. But if you interface it as a digital port, what happens? Only whether it is a 1 or 0 will be getted. So we can fix some threshold voltage. Once the threshold voltage is greater, it gives an indication as 1. So normally we prefer to use an analog interface of that sensors. So we need to use a signal conditioning also. So from the heartbeat sensor, with the signal conditioning only, that will be interfaced with the microcontrollers. Look at this second sensor, steps measurement sensor. So how many steps you are moved, so how many steps you are moving. So these things will be measured with this steps measurement sensor. Look at this blood pressure. So blood pressure will be monitored continuously. So for that we need to have this blood pressure sensor. Depending upon our requirement, we can include that sensors. This is the basic temperature measurement sensor. So we can measure the temperature meter. Accelerometer. So these sensors will be used to track the positions. So whenever we have that body position or other things, so this will be detected with this accelerometer sensor. Humidity sensor, so to measure the humidity values. So normally this will be used in agriculture. For human bodies also, to measure this humidity, we can use this humidity sensors. So all these sensors are in analog manner. We use this signal conditioning and that will be connected to the microcontrollers. So design consideration and major challenges. So first is size is the most important constraints. Because it's a wearable device, we cannot have a higher sizes. So first thing, the most important, the size is very small, that's a lightweight, and it is size will be small size. Weight should not be higher and then size should not be higher. So we should have a small size and lightweighter. So we need to use this smaller packages and advanced packing technology to make this integration is perfect to make a small size. And then components, there is an external components should be a minimum so that the size will be small. Second one, super low power consumption. So normally we use this VLSI technologies, still we need to reduce the power consumption so that frequent charging will be reduced. So battery cost also will be reduced. So for that we prefer to use CMOS technologies. So power consumption is very critical because it's a battery operated. So we need a minimum power consumption in this. So that we have used this limited battery life and then avoid frequent charging, and then cost also less if you use a low power consumption. Again this low power consumption chip that will be good for a standby time will be very high and then usage time also high. So this low power consumption microcontroller units can be used so that the total power consumption can be optimum. Again this low power connectivities, because we need to use this Bluetooth or Wi-Fi. So these wireless technologies consume more powers. So normally if you take a mobile phones, so normally what we do, so whenever you are not using, we need to turn off this Wi-Fi's and hotspots because it consumes more power. So we prefer to use low power connectivity technologies, so which consume less power, that will be given importance to use your products. Human engineering design, so it should be an easy to use, then only the customer will attract and they will be ready to use. And foolproof design, so this should be a foolproof design for make the compact. And high reliability and then high sensitive sensors must be used. So reliability means when you are buying a product, it gives a good result. After 1 year, if it is not ready to give a good result, the customer will not prefer this. So it will give a reliable performance throughout that. So next point will be high reliability. So different environment, different climate conditions, different aging parameter, everything it should have a reliable results. Again, good mechanical design to prevent the damages. So it should be hard enough to maintain because customer will use roughly. So due to that, if it is damages, customer will be dissatisfied. So for that, we need to have the good mechanical design to help the device to be safe. Look at this, even if your mobile phone falls from a table, maximum possible cases it should not be break. Some devices must be a waterproof, some cases, so we need to have this waterproof technologies also. And then sensor technologies, instead of single sensor we can use a multi-sensor to increase the accuracies. And then sensor selection material, it should be a good biocompatibility, so then only we gives a better results. And then high sensitivity with a low power consumption. Our sensors should be a high sensitivity so that even small variation can be predicted. Also it should be a low power consuming devices. Connectivity technologies, we can use so many connectivity technologies. So we prefer to use this low power Bluetooth, Wi-Fi connectivity to access the other devices, because without connectivity it is not possible, but with the connectivity should not consume more power also. So we need to use the low power wireless technologies. So data synchronization also important, because so whenever you have a system, the data will be updated in cloud. The local system and cloud system data should be synchronized frequently. Then only we have the same data in cloud and local system. If not, the cloud's data is completely different from local data. So synchronization is frequently required, and then automatic upgradation. So whenever we are releasing next versions, the automatic upgradation facility also to be given.